pressure. So pressure is a force over area. Okay, this is the symbol, and this is the unit. So for the gas or liquid, we identify it as a pressure, but for solids we call it as a stress. So this is the common units that will be used for the calculation. Okay, we have absolute pressure, which actual pressure the given position and measured relative to absolute vacuum, and the gauge pressure, difference between absolute pressure and local atmospheric pressure. The vacuum pressure is difference between atmospheric pressure and absolute pressure. Absolute, gauge and vacuum pressures are all positive quantities and related to each other by these equations. So for the pressure above P atmospheric, for pressure above atmospheric pressure, the equations became P gauge equals to P absolute minus P atmospheric. But for the pressure below atmospheric pressure, the equations that we can use is P vacuum equals to P atmospheric minus P absolute. So this represented by this diagram. Okay, so this is the level of P atmospheric. Okay, and for the pressure below P atmospheric, so this is, we have P vacuum. This is P absolute. So or we can put it like this: P atmospheric is equals to P vacuum plus P absolute. Okay, P atmospheric equals to P vacuum plus P absolute. But when we rearrange the equation, it becomes P vacuum equals to P atmospheric minus P absolute. So it's just the same. Okay, so for this one, this is the P atmospheric. Okay, so if the pressure is above, okay, the pressure above of P atmospheric, and so as you can see, the absolute pressure is higher than absolute pressure. Therefore, the equation that we are going to use is this one. Okay, P absolute, or we can put it like this: P absolute equals to P atmospheric plus P gauge. Okay, so we arrange the equation. P gauge is the differences between P absolute minus P atmospheric. So where we get these equations. Can you understand that? Okay, so intermol absolute pressure is always used unless stated. Manometer. So this is the manometer looks like. So it is a small to moderate pressure differences are measured by a manometer, and differential fluid column of height H corresponds to a pressure difference between the system and the surrounding of the manometer. So as you can see, this is an example of a tank. We have tank of gas. Okay, so this is the manometer. The fluid flows at here. So as you can see, this is if we make it as 0.1 at here. So we have gas and we have liquid at here. So the differences between the level of the liquid and the gas at and the beginning of the liquid at here until here. Okay, so this is the differences, and the differential fluid column. Okay, represented by the height. Okay, which this one is correspond to a pressure difference between the system and the surrounding of the manometer. Okay, so this is the surrounding of the manometer, and it is called as atmospheric pressure at here. Atmospheric pressure which push the liquid. Okay, so the delta P is equals to rho GH, density, gravitational acceleration, and height. This is the equation that we're going to use. So remember, this is the level number 1. Okay, level between 1 and 2. Okay, until the end of the liquid. So the differences of level is represented by the height. Okay, H, and this is the representing the differential of pressure in kilopascal. So other pressure measurement devices, we also have Bourdon tube for the C-type or spiral. Okay, so and the twisted twisted tube, helical tube cross-section, and this is the modern pressure sensors which using pressure transducers, piezoelectric material.